Let's take a look at some mixture problems. So before we actually do a problem, let's understand what's happening here with a mixture. So let's say I have two beakers of solution. Solution means two things are mixed together. In this case, it'll just be alcohol and water. And so I have 80 milliliters of liquid. 4 milliliters of that is alcohol. So that means that I have 4 out of 80. I can just set up a simple proportion here, and that's going to be 5%. So we want to think about the concentration or the percentage that the alcohol makes up of the total liquid. So that means there's 76 milliliters of water, so it's quite diluted. Over here, we have 60 milliliters of liquid and 6 milliliters of alcohol. So that's going to be a 10% solution. So let's say I contribute some liquid from the first beaker, 20 milliliters, and some liquid from the second beaker, 30 milliliters. That'll give me a grand total of 50 milliliters. That should be the easiest part of what we do today, the grand total. The question is, what is the strength, the concentration of alcohol in this big 50 milliliter concentration here? Is it 10% from the original over here? Is it 5%? Is it the average of 5 and 10%? Is it 7.5%? Is it the total? Is it 15%? What is the concentration? So what you need to do is you just need to figure out how much alcohol is in this beaker. So remember how we started. We had total liquid and the amount of alcohol, total liquid and the amount of alcohol, and all you need to do to solve this problem is figure out how much alcohol is in that beaker. I know there's 50 milliliters total of liquid because once we figure out the alcohol, then we've got the proportion or the percentage, just like we figured out up here. That's how we figured out those percentages. So all I need to do is figure out how much alcohol is in there. And here's how we do it. So we'll take 5% of 20, which is 1 milliliter. 5% of 20. 10% of 20 would be 2, so 5% of 20 is 1. And then we'll take 10% of 30 milliliters, and that's going to be equal to 3 milliliters, correct? And so, now I know how much alcohol is in this beaker. There is 4 milliliters of alcohol in this beaker. And so the final question is, what's the percent or strength? That's going to be 4 divided by 50, x over 100, and that's simply going to be 8%. So the concentration, I took you through a little multiple choice there in the beginning. What was the concentration? 10%, 5%, the average, 7.5%, the total, 15%? It was none of those. You have to do all of the work. It's not a strategy where you can just figure it out in your head. You've got to figure out the total amount of alcohol in that beaker, and it comes from the percentages that each one of those beakers represents. So let's take a look at that one more time. And all I'm going to do is I'm going to change up the numbers. So notice this is 30 and this is 20 now, and before it was 20 and 30, right? So I'm just switching up the numbers. So we still have a 5% concentration over here and a 10% concentration over here. And so all I have to do now is do 5% of 30, and that'll be 1.5 milliliters. And then I just have to do 10% of 20 milliliters, and that's 2 milliliters. So now I have a grand total of 3.5 milliliters of alcohol out of a grand total of 50, and so that's 3.5 out of 50, so that's going to be 7% alcohol, 7% concentration in that beaker. All right, let's do an actual word problem. So here I'm giving you the solution percentages. 2% for solution A, 6% for solution B, and I want to mix the two together to get 60 liters. So let's take a look at the picture that's happening here. Notice that this is an algebra problem now, so there are different unknowns. I don't know how much total liquid is in beaker A and beaker B. I do know the concentration though. And here's what I do know now. I want a final concentration of 3.2% in my 60 liters. So the only thing that's different now, instead of taking 2% of, say, 20 milliliters or liters, I don't know what this is now. So now it's 2% of A, 2% of a variable. There's 2% of my variable. There's 6% of my other beaker. Why are we adding them together? Because that's what we did up here, right? We found the total alcohol, and that meant there must have been 3.5 milliliters of alcohol contributed in the 50 milliliters of liquid. And so, all I have to do now is compare that to 3.2% times 60. So what I do is I call this my alcohol equation, and then I call this my total liquid equation. So just like we saw above, 20 milliliters and 30 milliliters, that's going to make 50 milliliters. And then I took my alcohol, added to my alcohol, got a total alcohol. And so I have the same thing. Everything's just a variable now. So this is my total liquid, A plus B. And this is my total alcohol with all of my percentages. And again, this is pretty arbitrary what you want to make X and Y. It doesn't really matter in this case. And so let's go over to Desmos and let's take a look at these equations. And you can see I just typed them in relatively standard form. And you can also see that I let Desmos do the 3.2% times 60. Just type it in with the multiplication. So let's take a look. 18 and 42. So 18 is X, 42 is Y. And so, going back to our definition of variables, A was our Y variable, and A was our 2% solution. So how would we write a final answer? We would say 42 liters of 2%, and we would say 18 liters of 6%. And that's how we'd know. The A and B is kind of arbitrary. The X and Y is kind of arbitrary. I want to know what kind of concentrations I want to contribute.